So this video is all about drawing ray diagrams for lenses. We're going to start off with drawing ray diagrams for convex lenses. Those are the type, remember, that create real images. And we're going to start off with an example of where we have a real image from a convex lens. And so you'll see that I have my setup already done here. I have my principal axis, just like you have on a mirror. But one thing that's a little bit different is I also have a vertical axis here. That vertical axis splits my lens in half. Also, I put a focal point on each side of the lens. Each focal point should be the same distance from this vertical axis. And then I use the point 2f because we don't have a center of curvature on a lens. So I have a point 2f on either side as well. I've placed my object here outside of 2f. And so I'm going to start with a line that is similar to how we start with a mirror. Start at the tip of my object and draw a line straight across until it hits that vertical axis there. And then that line continues on through the focal point on the other side of the lens. Now in reality, we know when we go from air to our plastic or glass lens, the light would bend, and then it would bend again or refract when it goes through this surface. These diagrams ignore that fact, but they make them easier to draw the diagrams. So here's our first two lines, one straight across, parallel to the principal axis, and then the second line through the focal point, just like we do with mirrors. Our third line starts at the object, goes through the focal point to the lens, and then straight across parallel to that principal axis. And of course, just as we do with lenses, we should have arrows along the way showing the direction that these light rays are traveling. The point where these two refracted rays meet, these are those two rays right here. So this point right here is where the tip of my image will show up. And so I can draw my image, starting with its base on the principal axis and its points there. Just as in those 6 scenarios, my image is between f and 2f. It is real and inverted, and it is smaller than my object. Let's try drawing a ray diagram where we won't have a real image. Here's the same setup, except for this time I've moved my object to inside the focal point. So I'll start off with the exact same line that I had before, starting at the tip of my object, going to the center here. And then the second line is also perfectly fine. I can easily go through that focal point. But it's that third line where I run into problems, because I'm supposed to go from the focal point, I'm supposed to go from the object to the focal point to the lens, and that's not possible here. So instead, I should draw a line as if I'm going from the focal point to the object and then to the lens. Now looking at what I've drawn here, I'm going to run out of space. I'm going to run out of lens if I try going up like that. So instead, I'm going to cheat a little bit, and I'm going to make my object smaller. If I make it a little bit shorter, then I should be able to get to my lens. So let's look like that. And I'm also going to move it in just a little bit. So now I'll readjust these lines that I've drawn. And I'll draw that third line that I was talking about. Again, as if I'm going from the focal point to the object and then up to the lens here. I might run out of lens a little bit, and that's fine. It's not a big deal. After that, I would need to draw a line that starts where I left off here and goes parallel to the principal axis. Now you'll notice that these two lines that I have here, these two refracted rays, will never meet. They'll keep getting further and further apart as they go away from the lens. And so just as we did with mirrors, we're going to take these two refracted rays this time and extend them backwards as dotted lines. So give me a moment to switch my line over here. I'm going to take this refracted ray and go backwards with it. I'm going to do the same thing with this one, this refracted ray, and go backwards with it. That point where these two dashed lines meet, that's where my image now appears. So this time, my image is going to look something like this. Just as we've learned, my image is on the same side of the lens as the object, it's larger than the object, and it's upright. The final type of lens diagram that we have is when we have a concave lens. As we know, concave lenses always produce virtual images. So let's learn about those. The first line is always the same. We start off at the tip and we go straight across like so. But our second line here is different. It's different because unlike with convex lenses, concave lenses do not make the light converge. So instead of my light going through the focal point like this, that would be for a convex lens, the rays diverge. And the way to figure out which direction they go here is to draw an imaginary line from F to where you stop here and continue that line on upward. And so again, I'll put some arrows for direction along these lines. For my next line, I need to go through the focal point, but instead of going through this focal point here, I'm going to draw a line as if I would be going through this focal point. So it is as if I would go here, but this line stops at this vertical axis. And then after that, it continues straight. Put some arrows along that. So now I have two refracted rays that will never meet. They'll just keep getting further and further apart. So just as we do with virtual images on convex lenses, we're going to continue those refracted rays backwards as dashed lines. You'll see that I end up with a joining point here, and I'm going to put my image there. And just as we expect from what we know, I end up with an upright virtual image that is smaller than the object. I'm going to run through the steps of this one more time because this one's very different than what we've done. The first line goes straight across and then goes upward as if we were following a line that would go through the focal point. Now mine's not perfectly upward. I probably should actually have it better angled so that when I extend it backwards, this does go through the focal point. So just that right there. And then the next thing that I do is I draw a line that would go through the focal point on the other side, but I stop when I get to this middle line, and then I draw a line parallel to the principal axis here. These two refracted rays get extended backward as dashed lines, and the point where the two dashed lines meet gives us the tip of our image. Feel free to replay this video a few times if you'd like to go over how to draw these. It is expected that you will know how to do them by the time you come to class on Monday.